Hello webs, hi, this is Fahad from Future Phones, and today I have a HP laptop to repair that I have selected for this video. There is a few interesting things about this laptop that will increase our knowledge. I have taken this laptop out of the casing, and I will inject the power into this laptop. My power supply is set to let me just set this up. Okay, this is 19 volt and 5 amps. My power supply is set to 19 volt and 5 amps, and I'm going to connect this to this laptop. I think you should be able to see that in this small window over there on the top. So I'm just going to connect, and notice here that this light will glow red, and there is a sound as well this power supply generates, just to let you know that there is a power is being consumed in big number. So just kind of a indication. So let's check and let's see if you can hear that sound. Yeah, you see that? And this light was glowing red as well. So when this happens, this sort of laptops, they have the shortage on the main rail, and we have gone through with the procedure of fixing these before as well, but there is a couple of new things that I wanted to share with repairing of these laptops. So just selected this laptop for the repair. So if I put my multimeter into the diode range now, I don't know if you can see that, and I will go to the microscope here. So if you go into the microscope and we start from the charging port, because the main rail's job starts from the charging port, and you can see here we have two different types of MOSFETs, and I'm just going to check these MOSFETs if they are okay. Or you can see here, after these MOSFETs we have a current sensing resistor as well, so we can start our test from here also. So if I put in the diode range red probe on the ground and black to check if I have any short on these MOSFETs, so this MOSFET is clear, this is clear, this is clear, but here, okay, you see here on this MOSFET we have short, and this pad is connected to the current sensing resistor. So you can see this current sensing resistor is short on both sides. Now before we proceed, I'm going to check these two MOSFETs as well if they have the correct values, because sometimes they go faulty as well. Along with, when there is a problem like this, your power SRC or your current sensing resistor, because after this current sensing resistor is the main rail that goes to different areas of the board, and it provides required voltages to those sections. So before we go to check this current sensing resistor, we would check these two MOSFETs. Is always a good practice, because sometimes they come faulty as well, and you are checking the power SRC and you have fixed the shortage from this side, and if one of these is faulty, then you will have the problem again, you will have the shortage again, because if these MOSFETs are shorted, they behave like a line, like a power line only, without any providing any switching supply. So let's say because there is a gate, source and drain, so power from source to drain goes in switching format, but this power, let's say if we have 19 volt on this end, so this gate supply, which is this one, this gate supply will allow the power to go from this point to this point, from drain to source. So it's always a good practice to check these MOSFETs, and it's easy to check. You can see that if you put red probe on one side and the ground on the other, it should give OL, over limit, and if you put on the other side, if you swap them around, then you get the value which is 0.53. This is the value of a diode. When you check the diode, you get the value below 600. So anything 0.600 is good value. So this is a good value, good diode. If I check this diode, and you can see we have a value coming from this side, and if we swap the probes around, and you see that we have a over limit. So this diode is okay also. Now we have the current sensing resistor. To remove, how are we going to check this current sensing? We have to remove it actually. So when we remove it, then we can confirm that which side of the current sensing resistor we have the shortage, and this could act like a good point as well to inject the volt. So once I have removed this current sensing resistor from the side wherever there is a shortage, I can inject the voltage from my power supply, and we can find out with the heat signatures that where the shortage is. So let's remove this current sensing resistor. To remove this current sensing resistors, I was just experimenting and I was trying a technique before, so I thought I'd share you with you guys as well. So let's see, this current sensing resistor is next to this cylindrical capacitor. So if I use the hot air station here, then this will start melting this part, and it makes awful smell. So if you don't want that, then you can follow the technique that I'm going to use now. Okay, my soldering station is on. Okay, let's see. Let me use some flux first. Okay, what I'll do, I will inject the solder here with this soldering iron, and I will heat both sides of the pad, and you can see. So basically what it is doing is just bringing the low temperature solder to this current sensing resistor, and that will help us remove this current sensing resistor. I mean, could you try and check if it is good enough to remove with the tweezer? If not, then I can use my hot air station on a very low temp, like 300 maybe, 300, 350, whatever. Anything below 350 is okay. Like you can see, look, it's coming off, and once it comes off, then you don't have to worry about that plastic being melted. You know, so this plastic is safe now. It did not melt this time. That's good. So you could use this technique as well whenever there is some parts next to the plastic parts. So if you don't want to burn those plastic bits, you know, so it's easier that way. So we are again in the diode mode, and we will check here. So we have a good reading. So this side of current sensing resistor is good. Okay, we will check the other side, and you see we have a short on this area. So let's put this current sensing resistor somewhere. I can start examining the board, or I can inject the voltage. I mean, if there is something visible, it's easier. This 19 volt is going to this Usually it goes to these coils. From this current sensing resistor, output goes to these this section here. Especially look, if you see here, we have a capacitor, another capacitor, and this is a set of MOSFET, and then a coil. So 19 volt from that power SRC or current sensing resistor. This is usually connected to these capacitors. I mean, it depends on what the engineer wants to do with the board and how he has designed it, but mostly you can find cases like this. Okay, we are good on this side. Let's turn it over. That is Super IO. It's okay. This area looks okay. This connector is fine. Oh, we have a look. We have something here. Something happened here. Let's check this. Okay, so we have found something here, just adjusting, and we had a customer, so I had to pause this video. Okay, let's see what it is. Okay, this is another power line, and it's like there is a blown capacitor. So you can check this area. So instead of going for the voltage injection, we can focus in this area and we can check if there is anything we can find out. Okay, let's see. So we know that definitely something is wrong here. Okay, focus. So yes, we can see here. The first thing we can find out, like there's something wrong here, so we can check this area. And another thing, these capacitors, they don't look in a very good shape, especially this one. You can see it's kind of there is like a chip mark here, and it's probably cracking and breaking. Yeah, so this cap has seen better days, so I think we can start working from here, and we can check if there is shortage on these caps, because these caps are most likely, this is the same 19 volt rail or power SRC. So I am in the diode range now. Red probe on the ground, black connecting to the CPU, and we see we have a ground here, and we have a ground here also. Let's check here. Okay, so we have ground on this line as well, but this cap definitely I need to check this one. And we have something here as well. All this is short, so this cap was also showing, this cap was also beeping here. It's okay. I mean, I could just start by removing this cap, which is really faulty looking, like it's cracking, and I think this is the one. Let's add some flux. I could just use my soldering iron as well at the same time, just to speed up the things. Yeah. Okay, this one is removed. I'll remove this one as well. I'll remove this one as well. Okay, so all these caps, remove them. So that's not good actually. What happened there? Okay. This cap has lost, it has received some damage as well, but that is changing its color also. Okay, let's work on these two. So this is the chipped one, and this was slightly better, or we will check them both. Okay, still I'm in the diode range, and let's see if this is okay. So this is a shorted cap. There is shortage on this cap. So I mean, it was very obvious, it was very clear, because the shape this cap is in, it is not a very good shape. Okay, let's check this cap here, the small one which is here. Okay, this looks fine, so there is no problem with this one, but we have one shorted cap here, and this looks fine. Okay, so I'm going to remove these caps, and I'll use my donor board. Oh, it's a similar kind of board as well, because this board is quite good actually. It's got so many caps in it, and bigger size caps as well, so always saves me a day. I could start removing these two caps here. Okay, I think I could use these two caps, and so yeah, I forgot to do one thing. I did not check if we have shortage on the power SRC line anymore. Okay. So ground check. So this side was showing short before, so this shortage is removed now. This is ground pad, so that's fine. Okay, so we don't have short anymore here. Okay, I mean, this is fine. Okay, let's see what we can do for this. Okay. So first of all, let's get rid of these two caps, the faulty ones. And this is our donor board. Let's get them out. Okay. These okay, that's fine, and this is okay. That's fine. Let's give it a clean. This line is a power line, so if I think I'll remove whatever debris is here, because I don't want it to connect to the ground. If it does connect to the ground, it will cause short. But this is increasing. That's fine. Let's see what I can do for this. Okay. Alright, that's okay. Could use the UV glue here to save this area. Then you just need to clean first. If you can see that. Okay, it's clear to you now. Clear to me. Yeah. Okay, I'll remove this area anyway. This, I want this one. This is could be dangerous as well. I think this 19 volt is connected here also. I'll just check it later on. So I need to clean it. Okay. Let's use the UV glue. That should be enough. Don't want any dirt going in this glue. Solder mask actually. So solder mask. Ready to go. Here. Okay. Okay. Okay, I will just connect this bit. No, it's not right. Something is not right with this switch. What can I use it with? Okay, I have some USB cable here. Okay, I can use the USB cable. Yeah, that's okay. I will just, I think my computer does not like this light to be connected. I think I have given enough time for this solder mask to dry, and it should be okay now. Just give it, just let me remove this first. Okay, let's check. Yeah, it's much better. So we have these pads here. Leave it there. Let's check. Okay, go into the beep range, I think so this time. Yep. Okay. So it's not short to ground. This is ground, that's fine. Ground, 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 that's fine. No ground, no ground, no ground, that's fine. No ground, that's fine. Is this cap connected to this? Yep, that's connected also. Here, that's fine. So this there is a connectivity between these. So I can put one cap here also, or I could leave it actually, but I'll just put one on because I have put the soldering mask there, and if there was any connectivity with the ground on that ripped off area of the board, that soldering mask has covered it. So I'll use this capacitor from the donor board. We need to do is put that cap here. Okay, for this I will be using the flux first in this area and here also. Okay, let's connect it. Yes. Okay. So if I can connect this capacitor to these 2 points, that would be brilliant. It would be very easy. I don't have to put wires on then. I think that's fine. So this cap is good. Let's check if there is any problem with the ground here. We are in the beep range now, so this is not shorted. This is the ground we know, that's fine. This is ground we know. Okay, so I think we are on the right course at the moment, and our shortage at the current sensing resistor should have gone also, because that capacitor was shorting it to ground. See, oh, so we don't have any more short here. This area is clear. We can put our current sensing resistor back on. Okay, and there is plenty of solder on this current sensing resistor now. What I'll do, I could just lower the temperature, use soldering iron. Oh, sorry, you couldn't see that. So that's what it is. There is some excess solder on this current sensing resistor. My temperature at the hot air station is about 330, 300 now. I'll use the hot air and the soldering iron both together. I'll remove some of this excess solder later on. Okay, just I need some flux here. Yeah, that's fine. I will remove some of this excess solder from here. Use this. That's fine. That's nice. Let's give it a clean. Okay, let's give it power now. Okay, just one more time. Let's just check for the shortage. If the shortage is gone, so we're in the beep range. No, we don't have short on this side, we don't have short on the other side. We are going good. Okay, so we were connecting this this power connector here before, and we were getting a short on the power supply. So let's see if we are still getting this short. No, we are not. So we have good reading there, and the light has come on this charger, and it's not showing short anymore there. So I will check it on the screen. I'm quite sure our job is done. We should have a display as well, because not everything goes faulty. That's one thing to remember. Whenever there is a problem, there is usually one or two problems with the board, and if you can fix them, the rest of the board works quite fine. So this is my experience. I mean, usually there is only one thing which is faulty, and that holds the laptop or your device to power on. And once you have fixed that little problem, the rest of the board is usually okay. Yes, if your SoC something like major IC is faulty, then we have a problem that we can look at. Then it's a difficult one. If your SoC is faulty, then it's a difficult thing. I mean, it can be repaired, but is it worth it? I think one of these is the power. Yeah. Okay, we have a power. Do we have a display? Actually not, because we don't have the RAM connected to this board yet. So I'll connect one of the RAMs. I forgot to connect this. Okay, let's go one more time. Okay, diode mode, and with diode mode you can put this red probe on the ground and black probe to the connector, power connector, the connector for the power button. You can connect it. One of the pins is the very safe way to power it on, actually. So better, 100 times better than a tweezer, because if you use a tweezer and you connect a different pin, then you could have a problem. You could even create short. So give me some display. Okay, we don't have it. Oh, it's a joke now. I did not connect the LCD connector. Oh no. I'm just wasting time. Oh, no. Okay, let's power it on again, third time. And do we have a display? Yes, we have a display. Look, we have a display. So we are okay. I mean, this is fixed. So sorry for wasting your time a little bit, but I'm quite sure you must have learned something from this video. And if you have learned something, and if you enjoyed this video, like and subscribe to the channel, and leave some comments in the comment section if you have any questions to ask. Thank you for watching, and we will see you in the next video. Thank you. Bye.